Well, good evening, students. Okay, so today we will be discussing about the definition of a vector. It is like you already have learned what is a vector. And suddenly when I say we are discussing about definition of a vector, you might think, "Arey, vector mein kya hai? What is so special about a vector? Vector only has a magnitude and a direction. That's it, right?" Okay, so is that the definition of a vector? So which means any quantity that has a magnitude and as well as a direction. Can you term that as a vector? Okay, this is the question. Now, towards it, let us try to answer this question. A very simple question I have asked. The direction of current in a circuit is shown below. The current is it a vector or a scalar? 99 out of 100 students, okay, have answered that this is a vector. Where is that 1% going out? If you ask me, then it is of me, only me, who have answered that this is a scalar, because I know the subject. Okay, a teacher knows it. So after understanding, in fact, when I first read this question, I also thought that this is a vector. Then I realized, okay, after flipping back the pages, the answers, this was a scalar. I looked for the reason. Then I understood that current is a scalar quantity and not a vector quantity. Now let us understand the reason behind it. Now, what is a vector? A vector is nothing but an entity which has both magnitude plus a direction. This is the conventional way of defining a vector. Okay, because most of the time it satisfies. When I say most of the time, okay, there could be one time where this may not be satisfied. That is this particular case. Actually, the answer here is not a vector, but it is a scalar. A current is a scalar. Now let us see how current is a scalar. Now towards it, let us take two vectors. One vector, vector A, let us say the length is 3 unit. The another vector, vector B, which is 4 unit. Now, if I give you two vectors like this, and I ask you, what is the resultant of this vector? What is the answer? The answer is so simple. You will always say, hey, there is nothing. We have already learned vector addition. Put A here, put B here. And then this is your 3 units. This is your 4 units. Sum of these two should be like this, which is 5 units. Right? Good. Good to go with. You have already learned vector addition. Now let me assume, since this is current is also a vector, that's what most of the students opine. So what I do is, let me consider a current flowing in a wire, which is 3 amperes. And you have another current flowing in this wire, which is 4 amperes. And let us say these two vectors or these two currents join together, okay, and pass through another wire. Now, if I ask you, what is the total current passing here? According to you, this 3 square plus 4 square should be 5 square, or this should be equal to 5 amperes. But is this 5 amperes? No, it's not 5 amperes. You just say that 3 and 4 will add together to give rise to 7 amperes. Why 7? The reason is because we have used something known as the Kirchhoff's current law, right? If you know this Kirchhoff's current law in electricity, you will understand this. Or also you can say that, okay, the currents, we just add it like this and we say total current is equal to so much. Thus, you see, an important rule in vector is that apart from saying magnitude and direction, you should always say vectors obey addition rule of vectors. Or you can say vector addition rule or parallelogram law of vectors. Right? You remember this, okay? So if it obeys a parallelogram law of vectors, only then you can say that the entity that you are describing is a vector. If it does not obey, then definitely it is not a vector. Though the current should be represented by a magnitude, and also by a direction, see sideways, upwards, downwards, whatever it is. But still, it does not obey the parallelogram of law of vectors, and hence a current is not a vector, or this is a scalar. Hope this helps. I have clarified it. Thank you, friends, for watching. So in tomorrow's video, we will have a look at uncertainties, errors, or misconceptions in an error. While you do error calculations, what kind of misconceptions do people have? Okay, with this, thank you for watching this video. If you like this video, like, share, comment, and subscribe for more such videos. It would be a great encouragement for me. Thank you.